Hello friends, today we are going to cover second part of data type variables and arrays. Okay, we are starting with character escape sequences. Those are used in string literals while system.out.println is used. So here is the escape sequence. First escape sequence is /DDD. It is octal character. Then /U 4 times X hexadecimal Unicode character. /single quote for single quote. /double quote for double quote. These all sequences are used for display this particular value while printing the message. // is for backslash. /R for carriage return. /N for new line. /F for form feed. /T for tab and /B for backspace. Then we are going to see string literals. String literals are specified by enclosing sequence of characters between pair of double quotes. So whatever written inside the double quote pair, it will be considered as a string literal or a string constant. So these are the examples. Hello world, 2/n lines means 2, and then new line lines, and then / double quote is for displaying double quote. This is it quotes. String literals must be begin with and end with the same line because there is no line continuation space escape sequence present in Java, like in C and C++. And one more difference of strings in C and C++ and Java is strings are implemented as arrays of characters or group of characters in C++, but in Java strings are actually considered as object types because string is an inbuilt class that is defined to operate upon strings, like concatenating two strings, then comparing two strings, then finding out the size of two strings, or finding out any particular character in a particular string. So all these methods are defined in string class, and the string class value, whatever you will declare as a string object, will be considered as a object. So it is not a arrays of characters like in C and C++. Now variables. What are variables? Variable is a basic unit of storage in Java. So whatever you will compute in Java, whatever you will calculate in Java, whatever you will operate upon in Java will be stored in a variable. So variable is unlike a constant in Java. Variable means a variable that will be having a value changed. So every time you are operating upon, every time you are calculating upon, its value will change. It will not be constant. How to define a variable? Defined by combination of identifier, type, and optional initializer. So identifier is the name of variable you will specify. Type is a data type of variable, and optional initializer. So initializing is not a compulsory thing, but I recommend every time you create an initialize, you should initialize the variable because it prevents from storing the garbage value inside the variable. All variables have scope, which defines their visibility and lifetime. So scope is what? We will see scope in detail in future. But for now, what is scope? For opening and closing curly braces. Opening and closing curly braces, everything is written inside that opening and closing curly braces will be declared as a scope of that variable. So whenever you are writing a variable, declaring a variable inside opening and closing, the scope will be inside that particular block. Now, how to declare a variable? In Java, all variables must be declared before they can be used. So firstly, you have to declare it. How to declare them? Data type identifier is equal to value, comma, identifier is equal to value. So type can be any one of Java's automatic types. It can be class, it can be interface, it can be data type. Identifier is the name of the variable. Initialization is optional. Initialize the variable by specifying equal sign, and on the right hand side you should specify a value. Initialization expression, that is equal to value, must result in a value of the same or compatible type. If you are storing integer type of value in the left side of is equal to sign, and you are giving a value that is not compatible with integer like string, so it will throw an error in Java. So is equal to sign's right side and left side must be compatible. To declare more than one variable of the specified type, use a comma separated list. So like in this example, if you want to declare one or more identifiers one by one, so you should specify using comma. So one identifier is equal to value, this will be of type given here. Then comma identifier is equal to value, this will be also same type because it is comma here, it is not semicolon. Now examples of variables are here. Integer a comma b comma c is it declares three integer a, b and c. Integer d is equal to 3, e and f is equal to 5. In the first example, those are variables are only declared, not value is given, that is not initialized. In the second example, e is not initialized, but d and f is initialized to 3 and 5 respectively. Then byte z is equal to 22, initializes z, declares an double pi is equal to 3.14159, declares an approximation of pi, and character x is equal to in single quote x. So these are the examples of variables creation and definition. Then dynamic initialization. Here we have seen initialization of variables using equal to sign. This is called as static initialization. Static means at compile time itself, it will store the value, for example 3 to d, it will store value 5 to f and so on. But what is dynamic initialization? This is allowed in Java. Java allows variables to be initialized dynamically, that is at runtime using expression. When you are giving any expression, when that expression will be evaluated at runtime, when you are running your program and your expression is evaluated, its value will be calculated, and to the left side of the equal to sign it will be stored. So dynamic initialization is allowed in Java. For example, computing the hypotenuse of right angle triangle given in the length of its two opposite sides. Dynamic init example is given here. Here I have created two double variables, double A 3.0, B 4.0. Both are double variables because those are comma separated. Then I am creating double C. But how I am initializing this double C? Dynamically, means using expression. So when this expression will be evaluated, its value will be calculated and stored in double C. So what is the expression? Math dot square root a into a plus b into b. So what is a into a? 3.0 into 3.0. It will be evaluated to 9.0. Then b into b, 4.0 into 4.0 is equal to 16.0. The 9.0 plus 16.0 will be evaluated to 25.0. And then math dot square root of 25.0 will be evaluated to 5.0. So output of double C will be 5.0. So this is the example of calculating hypotenuse of right angle triangle is using dynamic initialization. And output of this is 5. Then scope and lifetime of variables. Java allows variables to be declared within any block. So what is block? Basically opening a curly brace and closing a curly brace. In between whatever you will write, that will be your block of code. So this is called as block. Block defines a scope. So whatever will be declared inside this scope, it will be destroyed out of this scope. If this method has parameter, they too are included with the method scope. As a general rule, variables declared inside are not visible outside. That is, whatever you will declare inside this opening and closing curly brace will not be visible outside or accessible outside of this after closing curly brace. We will see one example for this. Scopes can be nested. For example, each time you create a block of code, you are creating a new nested scope. Nested scope is as such, when you are creating one block of code, inside that you can create another nested block of code. When this occurs, outer scope encloses the inner scope. So outer scope will include inner scope, inner block of code. This means that objects declared in outer scope will be visible within the inner scope. So you will have opening and closing bracket. Inside that you are having particular code, and after that inside also you are having opening and closing curly braces. And that in inner closing curly braces, opening and closing curly braces will access all the data members and member functions in the outside opening and closing curly braces. But reverse is not true, means outer scope will be visible to inner scope, but inner scope will not be visible to outer scope. This is the example of scope of the variable. Here I have declared one variable, integer x. It is global variable. It is known to all code within main function. It is initialized to 10. If x is equal to 10, then I will go inside and I am declaring, very important line here, declaring y with 20. So what is declaration? Declaration is, we have already seen, data type variable name is equal to value. This line is called declaration. Okay. If this would be only definition like y is equal to 20 and int y is written over here, int y comma int y semicolon, then declaration would be global, and then this y would be also global like x. So it could be accessible throughout the code. But here int y is equal to 20, declaration is inside the scope, so y scope is limited to this much only. So known only to this block. X and y both are known here. Now I will print x and y, and then I multiply y by 2. Here again y is equal to 100. I don't know this y. Why? Because this is declared inside the opening and closing curly brace. So here it will throw an error. But x is still known here. So x is outputted like x is plus x. So x output is 20. That will be displayed. Now we will see some important points regarding variables. Within a block, variables can be declared at any point, but they are valid only after they are declared. You can declare throughout your code any place, at any place you can declare the variable, but before usage you should declare the variable. After usage, if you are declaring, it will throw an error because compiler does not know what type of variables you are creating. So you have to specify before usage that which type of variable I am creating. Okay, and what is the initial value, that is initialization part. If you are declare at a variable at end of block, that is also not allowed because it is useless. No code have access to it. So whatever you are doing, you should first declare all the variables and then you should use those variables. Here is the example, count is equal to 100. Okay. So firstly, I am defining count is equal to 100 and then I am writing int count. Variables are created when their scope is entered and destroyed when their scope is left. So what is scope is entered and scope is left? When opening curly bracket is started, the scope is entered, the variables are created, and then when closing curly bracket is done, that is variable will be destroyed after that point. Variable will not hold this value once it has gone out of scope. That is called as lifetime of variable. Therefore, variables declared within a block will not hold their values between calls to that method. So what is the we have seen call by value and call by reference in C++. But in Java, we do not use pointers, so call by reference is not allowed in Java. So because no use of pointers is there. But whenever you are calling to that particular method, the method is another block of code uh, that is different, that is at different place that than your main function. So when you are calling that method, some copy of that copy of values will be there when you are processing that method. And when that method is completed, when you are coming out of out of that method to again to that main function, the values, whatever values those are hold inside the copied variables inside the method, will be destroyed after that method call has been finished. So variables declared within a block will not hold their values between calls to that method. So again and again, if you are calling the same method, each time new values will be given to that particular variable inside method. Okay, so each time new values will be initialized and new values will be destroyed. If variable declaration includes an initializer, means what? If variable declaration is equal to value, if you are declaring with a value, then that variable will be reinitialized each time the block in which it is declared is entered. Means each time you are entering into the scope, every time if you are initializing the variable, so every time it is entering into the scope, every time new value will be stored into that variable. So every time lifetime of variable will be understood. Now Java's automatic type convergence. So this is very important point. If you want, you can write it down. When one type of data is assigned to another type of variable, one data type of data is assigned to another data type of variable, an automatic type conversion will take place if two conditions are met. So following two conditions are very much important. If you want, you can write it down. The two types are compatible. If the equal to signs right side and equal to signs left side, both types are compatible, then automatic conversion will take place. Or the destination type is larger than the source type. So source type is right side and left side is a destination type. If the destination data type is larger than the source data type, then also automatic data type conversion will take place. So two conditions should be met. Two types should be compatible, or the destination type is larger than the source type. Now lifetime of a variable we will see. Here class lifetime is created, one variable x is created. Now this is the for loop. In for also we use opening and closing curly brace. So inside the opening curly brace I have declared one variable and plus I am defining it y is equal to -1. So here it is printing y is y. So -1 to -1 it will be initialized first time, then it will be again modified to 100, y is now 100. Again after the closing brace the y is destroyed. Again the next time y will be again initialized to -1, again it will be 100. So three times the output will be -100, -100. Y is -1, y is now 100, y is -1, y is now 100. Although blocks can be nested, so you cannot declare variable to have the same name as one in outer scope. Blocks, you can nest blocks, you can have scope of variable scope block inside the another scope of block, but you cannot declare variable to have the same name, because outside variables are invisible to inside variables still cannot be visible to outside variables. So scope error, here is a example, integer bar is equal to 1 and new scope is created. So inner scope will have same data type, same variable name and different value. Int bar is equal to 2. It will throw an error because this bar is visible to outside bar. So you can rename it rename the inside bar with the new name. Now, type conversion and casting. It is fairly common to assign a value of one type to another type. If two types are compatible, then Java will perform the conversion automatically. It is possible to assign int value to long variable because long can hold long integer data. But not all types are compatible, so not all type conversions are implicitly allowed. So automatic conversion will not take place for all data types. There is no conversion defined from double to byte. Fortunately, it is still possible to obtain a conversion between incompatible types using casting. So casting is what? We perform the type conversion explicitly. So you have, it will not be performed automatically. You have to explicitly perform this casting. For that, you have to use the cast, which perform explicit conversion between incompatible types. So we have already seen rules for casting compatible types. Now we will see casting incompatible types. Although the automatic type conversion are helpful, they will not fulfill all needs. So every time Java programs are not so small that every time automatic conversion will be fulfilling all our needs. So for that purpose, we may require at some time to convert the data types explicitly. What if you want to assign int value to byte variable? What you will do then? You will explicitly cast the variables. This conversion will not take place automatically because byte is smaller than int. This is the narrowing conversion. So the destination type is less than the source type. For that, you have to explicitly convert it. For casting incompatible types, you must use a cast explicit type conversion, general form, target file type and value. So when you are explicitly converting, the Java is providing explicit type conversion in programming, Java programming language itself. So you can easily convert from one to another data type. Here target type specifies the desired type to convert specified value to. Here int a, byte b. So b is equal to byte a. Why we want to cast? Because byte is smaller than int. So this is the example of casting incompatible type. A different type of conversion will occur when floating point value is assigned to integer type. That is called as truncation. Truncation means what? Whatever written after the floating point will be automatically deleted. It will not be saved while it is stored in the integer value. Integers do not have fractional components. So whatever will be written after the decimal point will be removed, and only the main part will be saved in the integer variable. When a floating point value is assigned to integer type, the fractional component will be lost. For example, if you want to convert 1.23 to integer, only 1 will be saved to the left side of the equal to sign. So now we will see example. Here there are three variables: byte b, int I 257, then double d 323.142. All these examples, those are created and displayed in the PPT or PowerPoint presentation, will be explained in the practical part also. So you no need to worry if you are not understanding it. Still you have a chance. When you are seeing the practical part, you will definitely know how it is working and how it is displaying the output. So you just listen to theory, you just concentrate on the theory part. So first of all, conversion of int to byte, b is equal to byte I, then I and b is printed. Then conversion of double to int, d to int. Again the explicit type conversion is taken place. Then again d and I is displayed. Then double to byte. The double to byte is done and it is displayed. So output is see here, conversion of int to byte, I and b 257 and 1. I is 257, B is 1. Conversion of double to int, D and I. 323.142. Here fractional part is lost, only 323 is remained. Conversion of double to byte 323.6142, and the byte value of this is 67, which is displayed over here. Now automatic type promotion in expression. Other than assignment, expression also certain type conversion may occur. In expression also we can convert the data type. The precision required for intermediate value will sometimes exceed the range if either operand. For example, if you are calculating some data, and while calculating an intermediate part, sometimes it will exceed the range if the either operand. So what is the example we will see here? Byte A is equal to 40, byte B is equal to 50, byte C is equal to 100. Okay, so now it will multiply 40 into 50, A into B, and divided by 100, and then we will store the value into D variable. The result of intermediate term A into B easily exceeds the range of either of its byte operand. So now A into B, when we are calculating A into B, it will easily exceed range of either of its byte operand. To handle this, Java automatically promote each byte or short operand to int when evaluating an expression. Here sub-expression A into B is performed using integer, not bytes. So when it is performed using integers, it will not exceed the range. Also, one more drawback is automatic type promotion can cause confusing compile time error. For example, byte B is equal to 50, and you are multiplying that 50 by 2. Cannot assign into byte. 50 into 2 are perfect byte values back to byte variable. But because these operands were automatically promoted to int while evaluating the expression, result also promoted to integer, which can be stored into byte without casting. So this will cause a confusing type error. You should use it like B is equal to byte B into 2. So this way, sometimes automatic promotion we do not understand. So you have to understand theory one by one. When we understand the theory of Java, it is very easy performing practicals. So theory is very important also at the same time as we are learning the practicals. Now write down these 4 rules while evaluating the expression type promotion rules. All byte and short values are promoted to int. First rule: if one operand is long, the whole expression is promoted to long. If one operand is float, entire expression is evaluated to float. And if any one of operand is double, the result is evaluated to double. Okay. So these 4 are very much important lines. You should understand it properly and write down them. Now you will see its example. Byte B is equal to 42, character C is equal to A, short S is equal to 1024. Int I is equal to 50,000, float F is equal to 5.67F, double D is equal to 0.1234. Now double result F into B, float and byte. Then int and char D into S, that is double and short. So result is here. So how it will be evaluated? One of the operand is float, it will be promoted to float, and the result of sub expression is float. Then C is promoted to int, one is int, so C is promoted to int, result is of int. And D value of A is promoted to double. Finally, these 3 intermediate values, float, int and double, are considered. Outcome of float plus int is float. Resultant float minus double is double, and final result is stored into double. So this way this expression is evaluated. Now last part of this is arrays. Array is a group of like type variables that are referred to by a common name. Array of any type can be created, may have one or more dimension. Array of any type, you can create array of any type, array of object, array of class, array of interface, array of data types, and so on. One-dimensional arrays. One-dimensional array is essentially list of like type variables. To create an array, you must create an array variable of desired type. Type, variable name, opening and closing bracket. Here type is equal to data type of array. Integer, month of days. No initialization, only set to null. To allocate memory, you have to use the new operator. Array variable is equal to new data type and bracket size. After new, all elements in array will set to 0 automatically. So here is the example. Integer month of days is equal to new integer 12. So 12 values are assigned here, and third value, that is fourth index, is displayed. Month of days has this much days. April has this much days. So these all array variables are used to store how many days are there present in that particular month. Arrays can be created when they are declared. Array initializer is a list of comma separated expression surrounded by curly braces. So array will automatically created large enough to hold the number of elements you specify in array initializer. There is no need to use. So when you are there is no need to use new. So when you are doing initialization of array while creation, it will automatically assign the total number of elements value to that array. So how many values are there? 12. So array of 12 integer variables are created and all are initialized with this value. Okay. Java automatically checks at runtime if you are accidentally storing or accessing array elements that are outside the range or negative indexes. Then we are using multi-dimensional array. Multi-dimensional array is an array of array. Thus, if you might expect, look and act like regular multi-dimensional array. To declare multi-dimensional array, you will specify rows and columns. To declare multi-dimensional array, variables specify each additional index using another set of square brackets. This allocates integer 2D opening and closing square bracket and opening and closing 2 times opening and closing because it is a two-dimensional array. And here new int 4 is number of rows and 5 are number of columns. Here is an example. 2D array, integer 2D is equal to new int 4 and 5, integer I, j, k is equal to 0. Then 2D ij is equal to k, k plus plus. So here only declaration, 3 variables are for iteration. Here k's initial value is 0. In the first row, when I is 0, it is entered. For 5 times, for 5 columns, it will store the value of k. 0, then increment 1, then increment 2, then increment 3, then increment 4, then increment. Here j is less than 5, condition is not satisfied. So it will come out of the block again. I is equal to 1. For I is equal to 1, j will iterate again 5 times. Then 0, 1, 2, 4 is done. Then 0, 1, 2, 3, 4 is done. 5, 6, 7, 8, 9. Likewise, 4 times rows are displayed in 2D array. So this is the output. For displaying the output, second for loop is used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Now here we have seen fixed number of columns we have specified. We can also use dynamic number of columns for a particular row. So here number of rows are same 4, but number of columns for each row is different. For 0th row, number of columns are 1. For first row, number of columns are 2. For second row, number of columns are 3. And for third row, number of columns are 4. Here also 3 variables are used. Here also I am storing the value of k and incrementing k, and for displaying I am using second for loop. The output of this is for 0th row, number of row column is 0, 1. Then for second row, number of column is 2, and so on. So this is the output. So this way we have completed data type variables and arrays. In the next session we will see the practical part of this. So you will understand better this all part whatever we have learned in the theory. So meet you in the next session. Thank you so much.